My name's Jack Forrest. I'm a chemistry teacher at Stocksbridge High School. So, I've got two beakers. I need two chemicals. I need lead nitrate and potassium iodide. So I have a series of experiments in this lesson, each one designed to reinforce the idea that mass is always conserved. And when your group has these chemicals together, you're going to react them. I'm not going to show you that, I want you to do it. Okay? There should be a sign that tells you a chemical reaction's taken place. You don't need much, and you don't need exact measurements, so this is quite a Year 7 friendly lesson, as long as you have enough to show that chemical reaction takes place. So if I react two chemicals together, you get a really obvious colour change, which is great because that proves that a chemical reaction has definitely taken place. Every child in the room can point to that and say chemical reaction. And then when you place both beakers back on the balance, the mass will always read the same. And that proves that before and after, mass gets conserved in that chemical reaction. I purposely made sure that I didn't do the reaction in front of the kids at the front of the room because I want them to see for themselves the evidence of a chemical reaction taking place.
Before there were 132.23 and after it were 132.19.
Hopefully what they're going to find at the end of this is when they put both beakers back into the balance, the mass will actually be the same as what they started with. So even though the chemical reaction's taken place, the mass has stayed the same.
I liked the chemical reaction because it were unexpected, because I thought it were going to fizz and pop or something, but it just turned to an orangey, yellowy colour like orange juice.
I liked it when the two chemicals mixed together and it looked like orange juice. It's made me thirsty.
Most of the masses I saw around the room, they were different by about 0.1 or 0.01 of a gram. So those last two decimal places on there, that's not a very significant mass. 126 grams we started with, we finished with 126 grams. So in a chemical reaction, does mass get changed? Put your hand up if you think mass gets changed in a chemical reaction. We started with 126, we ended with 126 grams. Right, put your hand up if you think mass stays the same in a chemical reaction. Right, that's more like it. What I'm going to show you next is an experiment that's a bit of an exception to the rule, and I want to see if anyone in here can figure this one out. Another reaction I do is a common carbonate reaction, marble chips and hydrochloric acid. Now if you take the mass of the chips first and the mass of the acid in another beaker, you can get the combined mass of the reactants. This time, when you add the acid to the marble chips, you get a really distinctive fizzing reaction, so you know there's a reaction going on, there's your evidence, but you can see on the balance that it will actually go down. The mass will progressively go down as more carbon dioxide is released. And that gets the pupils to think about, well, we know the rule, mass cannot be created, it can't be destroyed. So why would the balance show that there's less mass? Go for it.
Is it because it's turned to a gas and some of the gas has left the beaker?
Absolutely excellent. So it's left the beaker, and so the balance can't detect it anymore. But does it mean that mass has been destroyed?
No, it's just floating around air.
Brilliant. And then finishing off, I give another demonstration, which they kind of enjoy because it's making popcorn. And you can show that even though small popcorn kernels, small volume, if you then cook them, so they have a big volume, the mass hasn't changed. The mass hasn't got bigger just because the volume's got bigger. It's stayed the same. So it's a lot of different experiments that reinforce the idea that mass is always conserved, never lost, never gained. So what's the number one rule we can say about this lesson then, about mass? Go on then, Liam, I haven't heard too much from you.
You can't change it.
Right, you can't change mass. So you can't make it, you can't destroy it. Unless you start to look at things like the sun and a bit of nuclear physics, but we won't do that for a few more years, so don't worry about that.
It was alright, my favourite part were noticing that you could not change mass at all.
I liked it because
I wish we could eat the popcorn, but we can't because the butter went off.